So in the video, I had done this first part. So the north, south, east, west. And then each of these do have a degree measure that corresponds to them if we're thinking about standard position, which is what our calculator does. So 0 degrees, 45 degrees, 90, 135, 180, 225, 270, 315, back to 360. So the reason I did this is when we get to our word problems, sometimes they'll say something like, the wind was going towards the east. And you'll be like, what does that mean? That means it's at 0 degrees. Or they could say, the wind is coming out of the northeast. So if it's coming out of the northeast, it's going towards the southwest. And then you'd say, oh, that's 225 degrees. Okay, and then the next part in your note said if you have an angle that's 30 degrees west of north, so you'd start at north and go 30 degrees towards the west. And then for us, in the angle that our calculator does, that would mean that it was 120 degrees from that standard position or the standard form. All right, so at the top of our paper, we're going to go ahead and write down how you could draw some different angles. Hi. Oh, yeah, not in here. No, you're good. So we could have angles that are written as north something east. So north something east. And those angles would go this way, and they would stop at the positive x-axis. They wouldn't be any bigger than 90 degrees. Because if they went further than that, then we would say that they were southeast, not northeast. We also have angles that go this direction. That would be north something west. And again, they would only go about 90 degrees because if they went further than that, they'd be in the third quadrant. They'd be considered south, not north anymore. We also have, they're south, we have angles that are measured as southeast. And those would only be in the fourth quadrant. Any further than that, they'd be north. And then we have angles that are southwest. So those would be starting at the bottom and going this way. And then we have one notation. So each of those, if you notice, they all count for one specific quadrant, and that's it. So northeast is only in quadrant 1. Northwest is only in quadrant 2. Southeast is only in quadrant 4. Southwest is only in quadrant 3. And then the last type of notation that we have is called bearing. And this one starts at north, and it can use any of the quadrants. So it could only go this far, or it could go this far, or it could go this far. It could go all the way around even. So bearing can use all 4 quadrants, okay? So when you are doing a story problem, it is more likely that they will give you the instructions in this type of notation because that's how the real world thinks of compasses. It is not likely that they will say 15 degrees and mean it the way we think of it from what we learned on the unit circle and that sort of thing. All right, so your calculator is set up differently than a compass. Okay, so I'm going to go ahead and draw that too. I'm going to say that this is for our calculators, and they start here at 0 degrees, and then they go that way. All right. So anytime we're doing a story problem, we have to convert it from this notation into what is appropriate for our calculator. And then when we're done with the story problem, we're going to take the answer from the calculator notation, we're going to convert it back into what makes sense, okay? So today we're practicing that, and then tomorrow we'll actually look at the problems. I don't want you guys to get confused by the notation and have that make the math harder than it really should be. All right, so if you look at number 3, they're just asking you to do some of these. I always have students who ask me if there's like some little formula that can help them figure each of these out. And it would really be, if I gave you guys formulas, I'd have to give you 1 formula for each of these, and then I'd have to give you 4 formulas for this depending on which quadrant it ends up in. And rather than give you 8 formulas, I'm just going to tell you to draw it and use common sense, okay? So I'm not going to give you formulas, we're not going to memorize anything, we're just going to draw it and use our common sense to figure out what the calculator angle is. So this one says northwest, so we're going to start at north, and we're going to go 45 degrees to the west. So that is the compass measurement. And then that means that our calculator measurement would be what? $135, yeah. So we have 90 from the first quadrant, and then we have the 45-degree angle they drew, and then altogether we would say that answer is 135 degrees for our calculator. All right, south, 22.7 degrees east. So we're going to start south, we're going to go 22.7 degrees. But for us, if we were measuring this using a calculator, what would we do? Yeah, so we would say 90, 90, 90, that's 270, right? 270 plus this would give us our answer, because it's past the 270 mark. So that would be 292.7. All right, if we did bearing 327, we've got bearing 90, bearing 180, bearing 270, bearing 327. So altogether that was 327. But for us, when we measure it with a calculator, we would go this way. So what would we have to do? Anyone have an idea? So the pencil part is 327. The red part is what we're trying to write. Okay. So if we do 360 minus 327, then that helps us find that little piece right there. So 360 minus 327 is what? 33. So that means this little piece right here is 33. And then when we measure the part in red, we're going to say 90 for the first quadrant plus that 33 gives us what? 123. All right, go ahead and work on that section. So go up through 10. Once you get past 10, it's going to be the backwards version of what we're doing, where I give you the calculator measurement and you tell me in real life terms what that would mean. So if you feel comfortable and you want to go on, that's fine. If not, you can wait for me and we'll do some more together in a few minutes, okay? All right, so if we look at number 11, it tells us that the standard form, so the math angle is 27 degrees, or sorry, 22.7. Oh, sorry, it's frozen. I know, so rude. There we go. All right, so the math version of the angle is 22.7. But they want us to do the bearing version of the angle. which means that we have to start at north and go clockwise. So what would we do to find that angle? Yeah, subtract it from 90. We get 67.3, perfect. All right, the next one, 213. So there's 90, 180, 213 would be somewhere over here. So are we doing a southwest or a southeast angle? West. And we know that because it's in quadrant 3, not in quadrant 4, so it's on the left side, which would be the west side. And so that means that we're going to measure it from here this way. So what could we do? How could we find that part? Yeah, we could subtract it from 270. So if you do 270 minus 213.45, you get something 0.55. $56.55. Okay. If we look at number 13, 97 would be just a little bit past the end of quadrant 1. So that would be northwest, good. And then how far is it from north? 7.4, yeah, good. Because 90 was the first quadrant, and so the 7.4 is how far past the first quadrant it went. So since we started at north, we went just that little bit. Yeah. All right, go ahead and work on those. All right, so this part right here is basically the last formula that you would be adding to your cheat sheet. And it's how you write a vector if all you're given is the length of the vector and then the angle that the vector would form. Okay, so, and that's different than everything we've done so far. We haven't done one yet where they gave you the angle like this. So if you were to think about this like simplified, then that would be like taking the magnitude and multiplying it. So we would say the vector is the magnitude of v times cos theta I plus the magnitude of v times sine theta j. You don't have to do it with the i's and the j's if you don't like that form. You could do it in the component form if you want. It does not matter. So when you draw a picture of the vector, the magnitude is the length of it. But when we are doing story problems, magnitude could be something like how much force is being put on an object for those of you guys who have done physics. Anybody? Physics? Yeah? So if they say like you're pushing against a box, that would be the force on it, that would be the magnitude. If you're talking about how much something weighs, that would be a force on it, that would be a magnitude. If you're talking about a speed, that would be a magnitude. So for us in pre-calc, we mostly talk about story problems that have something with speed to it, like a ball flying through the air or an airplane flying through the air or whatever. And so for us, when we do these types of word problems, we're going to look for a speed in there. So if you look at number 19, the magnitude of the vector is just going to be whatever speed they gave you. So for 19, the speed is 536. Now, the angle they gave us is not a math angle. It's like the angle with the word problem. So we have to convert it into a math angle because we're going to type into our calculator cos of that angle, and we have to have it in terms of math so we can use our calculator. So we're going to go ahead and say 32 degrees west of north, so starting north, going towards the west, 32 degrees. So if we were to measure that from standard position, what would we say that was? 122. Okay. So if we want to write the vector, we said that this part right here was 32, so we took 90 for the first quadrant and we added 32. So we would say the magnitude is 536, so 536 times cos of the angle plus 536 times sine of the angle. And you could either put the i's and the j's, or you could put a comma in between and put it in that component form. So whichever way you do it is totally fine. And then that would be the exact answer, because I'm not rounding anything. It's not very pretty, but it's what I have. And then if I want the approximate answer, I can go ahead and type this in my calculator. So for this unit, we're always in degrees. I'll do 536 cos 122. And then 536 sine 122. And then that's all we have to do. Isn't that so fun though? Man, I just loved that. Yeah. All right, let's try the next one. So 20 miles per hour, there's our magnitude. And then we have a boat, and it's going southeast. Is what, 143? The angle? The angle should be pretty big, because it's in the fourth quadrant. So it'd be somewhere between 270 and 360. You can. 323? Is that what it is? Okay. So we would say that our vector is 20 cos 323. I'll go ahead and put this in the component form. And then 20 sine 323. And then we can go ahead and figure out what those decimals would be. Not too bad? So today we're like setting it up so we know how to work with these angles so they don't confuse us. Tomorrow we're actually going to do the problems. Okay, so the setup part will be helpful. And then after that we're done learning about vectors. All right, that was it. We're like setting up the problems, writing vectors from them. Tomorrow we're actually going to look at some actual story problems. That's what that packet that I gave you that's a little bit longer. So the problems that we're going to do, we're going to say like a plane is flying and the wind is pushing against it. Where does it actually fly, basically? Just like the one we did. Okay, so this is a good one. It says the car is heading directly east, right? So if we look at the first page, what angle is directly east? 0 or 360, either will be good. So directly east, I would say, is a 0-degree angle. Also, make sure you do a good job of reading these problems, because I thought long and hard about, you know, the situations I was setting up, that they would be realistic and all that. You know what I'm saying? Mm-hmm. Mm-hmm. It doesn't matter what the units are. Yeah, it would just mean that like whatever problem you're doing, when you got the answer at the very end, you'd be like, oh, it's the same units.